Good afternoon. On behalf of Engineers Australia, I'm delighted to welcome you all to today's webinar discussing surface drainage in roads and pedestrianised zones. My name is Amanda and I'll be your host for today. Firstly, in keeping with our custom, Engineers Australia acknowledges the traditional custodians of the country throughout Australia and recognises their continuing connection to land, waters and community. We pay our respects to them, their cultures and to elders past and present. Before we get started, I'd like to acknowledge that today's webinar is being hosted with Engineers Australia's industry partner, ECHO. ECHO in Australia offers an extensive portfolio of stormwater, building drainage systems, cable pit and ducting systems, access covers and other niche products. ECHO take pride in providing excellent customer service and extensive technical support from specification to the finished product installation. Today, we will hear from two speakers, followed by our live audience Q&A, and I encourage you to send questions through to our speakers via the chat box. I'd now like to welcome our first speaker, Toby Hoy, Stormwater Engineer at the City of Ballarat, Victoria. Toby is a stormwater engineer and project manager based in Ballarat, Victoria, with broad experience across Western Victoria. With a background in civil construction, from estimating and tendering through to project delivery, he now brings a wealth of practical construction knowledge to the public sector. Since 2022, Toby has been working for local governments across Western Victoria in the flood recovery and stormwater engineering space, always on the lookout for opportunities for innovation in stormwater infrastructure. Please welcome Toby Hoy.
Thank you for the introduction. Thanks everyone for logging on to today's webinar. I'm going to start off by explaining the basics of drainage in a variety of situations. I'll then present a drainage problem for everyone to have a think about. While you're thinking, I'll speak about some standards that are resources for drainage design before coming back to discuss how I chose to manage the drainage problem. For drainage, we want to drain water from our trafficable and pedestrianised zones into our drainage network and to a final discharge point. We want to protect our roads so that they remain trafficable and safely by vehicles, and our pedestrian zones as well, so they remain safe for use. For our infrastructure, water damages pavements when it's able to penetrate the pavement itself or get beneath, causing flex of the pavement under load. Water can penetrate pavements from above, below, or from the side, so we have to get water off the surface and then take it away before it has a chance to infiltrate into the ground. Water is also a resource. We collect and transport water into natural streams, rivers, lakes, and oceans. We also collect water into dams and reservoirs for our treatment and use. Drainage considerations. Any drainage we design with existing infrastructure will need to work with existing flows and levels. We often have set levels both up and downstream that we must consider and match into. We normally have an upstream catchment we need to account for in our design. Regardless of upstream requirements, our drainage is going to have a required flow, and this is what's going to lead us to our size selection of our drainage infrastructure. Greenfield sites being the exception, we almost always have existing surfaces, buildings, and other infrastructure that we need to design around. Drainage infrastructure, especially under vehicle loads, has cover requirements, so we have to select a material that suits and has the strength to withstand the loads. For pipes, this is often a choice between concrete and HDPE, high density polyethylene, as these are the two most common pipe materials. We can also consider newer or innovative materials such as recycled plastic pipes. When lack of cover over pipes, flow volume or required loading becomes an issue, reinforced concrete box culverts or crown units become the standard product for use. For above our drainage structures, we have access covers and grates visible to people. Here we have an excerpt from Australian Standard AS 3996 2006, access covers and grates. This standard specifies load cases and gives them a class rating. Manufacturers typically design covers and grates to meet a specific load class. When designing drainage, we have to consider the land use where the lid or grate will sit. Different lids will normally be used for vehicle and pedestrian traffic zones. Grates in general should be installed perpendicular to traffic, for example in roadways, so that cyclists don't fall into them. Heel-safe grates is a common consideration for pedestrian zones. Drainage is typically managed either above ground or below ground. Here we have a typical above ground or open drain setup. Water runs off the road into the drains, as shown by the blue arrows, as the path of water flow. It then flows down the swales towards where the yellow arrow is, where there's a culvert underneath the driveway, and then in another swale or open drain to the right of screen. As we're using open drains, we'll need regular culverts under roads and driveways. Swales also need maintenance. In this case, the grass needs to be mowed or slashed. Occasionally may need to be reshaped due to organic buildup and washout repair after extreme weather events. Many open drains use alternative materials, such as brick or stones that have been split or cut. Ballarat was originally a gold rush town and still has many bluestone open drains that were constructed over 150 years ago. Another option regularly used, particularly for high flow areas, is to place loose beaching rocks in open drains to hold material in place and reduce the washout risk. For underground drainage, I have an example here of a new development a bit under 10 years old. All the services and infrastructure here were designed together. This is much easier than having to work around existing services, levels, and infrastructure. Now we'll zoom into the red box and have a closer look at where the water flows here. The road sheets both ways, left and right, towards the curbs. This road is at 2.5% grade. There's a legal point of discharge at the bottom left corner of the picture, flowing out into the curb. We also have driveways sheeting water into the curbs. In extreme events, the grassed nature strips will also sheet some water into the curbs. Once the water's in the curb collects the water and transports it to the side entry pit in the middle of the picture, and then the water is in our pipe network underground. In this case, the pipe heads under the road towards the right of screen, shown by the yellow arrow. Here we are back to the first picture, with the larger flows shown in blue and the underground flows shown in yellow arrows. Here our side entry pit on the left is there to capture the water from that side of the road and then pipes the water under the road to our main drainage on the right. Our main drain is under the curb on the right, coming towards the bottom right-hand corner of the screen. Now for our drainage problem. As you can see, we have a tree root that over the course of a couple decades has grown through our bluestone open drain. This results in water and leaves being caught behind the root to about 250 millimetres of depth. This area has many deciduous trees, so leaves add to the problem significantly in autumn and early winter. A small amount of water gets beneath the tree root and into the ground between the bluestones, but this isn't enough to clear the ponding. The bluestones were removed and we found that many more roots were below this main root, and there is not enough space to get water past the root that way. In the footpath, we have the power pole shown and two different telecommunication lines. Anything here couldn't be more than 250 millimetres of depth. The tree itself has been assessed to have a maximum 15-year lifespan remaining, and the root in question is structural for the tree, so cannot be removed, chopped or ground down. We have existing underground drainage nearby to the south. The community in the area didn't want the road, drain and footpath to look much different to how it currently looks, but they also want something done about the sitting water behind the tree root. These are difficult expectations to manage. A large-scale option that would have worked would have been to install new pits and pipes, or more likely box culverts due to cover issues, to capture the upstream flow and allow the remaining small amount of water to pass beneath the tree root. This would have utilised the existing drainage line to the south that this water enters anyway. Although it would enter earlier, it wouldn't have any capacity issues as it is already taking this current flow. This option would have been quite expensive and not met community expectations. Lifting the bluestone drain to the top of the tree root and adjoining road levels was briefly considered, but this would have required a significant amount of roadwork to lift the levels and provide a smooth transition for vehicles, as shown in the red bordered area. We would have also had to replace 2 property crossovers, as well as risk damage to the tree root from rot by building up against a tree root that is currently not underground. Another option would be to construct a pit or end wall in the bluestone drain to capture water and carry behind the concrete plinth next to the footpath in a grated channel. This would be cheaper than the first 2 options, but would still require a bit of work to tie into the bluestones and footpath, and would most likely not provide a neat finish. While this isn't always possible, it's good to aim for. We didn't end up implementing any of these options after I thought it might be worth trying something a bit different from the standard. Have a think about what you might do in this situation while I speak about some resources used by designers, and I'll circle back to what we constructed to manage this issue. Now, design resources. Many local councils and other government organisations in Victoria have their own infrastructure standards that designers and developers must follow. The Infrastructure Design Manual, or IDM, is a joint initiative that includes over 40 municipalities working together towards consistent requirements and standards for the design and development of infrastructure. In practice, this results in more consistent infrastructure requirements across different areas of the state. Austroads and VicRoads both have some good resources on their websites for drainage design, as well as a wide range of road-related infrastructure. Typically, companies sell off-the-shelf products with designs to meet various Australian standards. For example, precast concrete suppliers will make pits to a standard, such as IDM, and provide Class B and Class D lids designed to meet Australian Standard 3996 for access covers and grates, previously mentioned. Australian standards cost money to use for commercial purposes and have only recently become free to view for non-commercial purposes. Water authorities may also have resources available for drainage design, such as Melbourne Water, although this is not always the case, as some water authorities only manage water mains and sewerage, with stormwater drainage being managed by local councils. There are also other state and local government organisations that may have their own infrastructure requirements. Many will have similar requirements, but each one may have certain aspects that they require where others do not. Now, back to our tree root problem. Without further ado, we decided it would be worth a trial to replace the concrete plinth with a fabricated steel C-channel hot-dip galvanised, allowing the existing space of the plinth to be used as a flow path for water and leaves to clear. This is the result. While this doesn't solve the issue completely, this allows about another 150 millimetres of water to pass around the tree root with minimal disturbance to the surrounding infrastructure and at a cheap price compared to our other options. It also allows many more leaves to flow with the water around the tree root rather than banking up and blocking the water further. Our channel is anchored into a concrete block poured behind with an asphalt surface to match the rest of the footpath around the concrete and to match the area's infrastructure in general. Here we have some during construction photos showing the excavated space for the concrete block to be poured. Construction was in autumn last year, and as you can see, the leaf problem at that time of year is fairly significant. This sea channel should last well beyond this tree's remaining life and also has the opportunity to be reused at another location after that time, possibly with some small maintenance on the channel, such as galvanised paint or any sections of hot dip gal that have broken down. For the outlet end of the channel, we formed concrete to a 45-degree angle to direct water back into the bluestones and remove this space for leaves to be caught and sit in the channel. The sea channel has now been installed and operating for over 15 months. It hasn't been moved yet, over 1.5 autumns and almost 2 winters. So we hope that we will achieve our goal of getting the water past this tree root for its remaining years. Thanks for listening, everyone, and thanks to Engineers Australia for providing the platform to speak. For my parting words, I'll leave you with a Leonardo da Vinci quote: "Simplicity is the ultimate sophistication."
Thank you, Toby, for your input. I'd now like to welcome our second speaker, Kate Jennings, Specification Representative at ECHO. Kate is the Specification Representative at ECHO, overseeing projects across New South Wales and the ACT. She works closely with engineers, architects and hydraulic engineers, offering free project consultations to help deliver effective drainage and infrastructure solutions. In addition to supporting projects, Kate also facilitates CPD events and product presentations to keep industry professionals informed and up to date. Kate is dedicated to providing innovative products, technical expertise, and practical tools that support the success of every project. Please welcome Kate Jennings.
Thank you for coming along today. My name's Kate and I look after engineers, architects and hydraulic consultants in New South Wales and ACT. Before I go on, I'd like to thank Engineers Australia for hosting this webinar. My presentation today looks at drainage methodologies in roadways and shared spaces, along with all of the key considerations that must be made by designers when selecting drainage systems in these applications. And we'll begin by looking at surface drainage in roads specifically. With modern road drainage design, we have a lot of challenges from our growing population. So as our population grows and cities become more and more densely populated, engineers are being tasked with designing effective road networks and integrating drains and other services into narrower and narrower road corridors, either to widen or to reconfigure existing roads or add lanes for turning bays at intersections. And beyond just trying to fit more into a smaller space, other challenges include connecting into an existing stormwater system that perhaps can't cope with the increased flows from new developments and trying to avoid clashes with underground services. Of course, the primary objective of road drainage is to ensure the safety of all road users, whether it be motorists, pedestrians or cyclists, by reducing the depth and width of flow within a road. Managing, reducing or eliminating sheet flow and the spread of gutter flow will minimise the risk of hydroplaning and vehicles losing control, as well as slips, trips and falls from pedestrians. There are 3 traditional types of road drainage inlets available: side entry inlets through openings in the curb face, grated gully pits positioned in the gutter, or a combination of the two with an extended side entry. All of these traditional methods allow for intermittent capture of surface water. You can also capture water continuously rather than intermittently, either by using grated trench drains or slotted curb drains. These are very much problem-solving solutions and would be used in areas that are very flat with minimal fall or have services in the ground close to the surface. These continuous capture systems are more cost-effective solutions than installing closely spaced traditional curb inlet pits and deep pipe work, and we'll look at that in more detail later on in the presentation. Let's focus now on continuous capture inlet systems. So at ACCO, we've been selling our drainage channels in roads across Australia since the mid-1990s, but they became a really accepted method of draining roads back in 2013 when Austroads released the Guide to Road Design that cited these products as solutions. It was written with a consortium of all of the state road authorities, although there is some individuality in various states and territories. So there are a number of products for draining roads available in the market: graded trench drains, combined curb and drainage systems, monolithic channels and slot channels. Graded trench drains are one of the more popular type of continuous capture inlet. Due to the rainfall variance in Australia, 200 or 300 millimetre wide channels are commonly specified as they're compact and have variable depths to ensure that runoff is discharged efficiently. There are generally three types of grates: high flow with large apertures, heel safe with smaller apertures for pedestrian safety, and transverse slotted grates. These grates must be load rated to a Class D in AS 3996 and preferably fitted with boltless locking mechanisms that allow for quick access for the maintenance team to clean out the trench drain, but secure the grate in the channel. High intake grates with large slot sizes also allow the channel to be cleaned without actually having to remove the grates. A sucker truck with a high pressure washer is used to break up any sediment within the channel and wash it down to the vacuum pump, which sucks up all of the suspended silt into the truck. All of this can be done without unlocking and removing any of the grates. Looking at the actual drainage channel itself now, precast polymer concrete channels have a very smooth internal surface and are available with built-in slopes to remove water effectively from flat areas. Hydraulically, a V-shaped profile channel creates higher velocities during low flows compared to U-shaped channels or flat-based channels. This promotes self-cleansing to help keep the channel clear of debris and silt. And in precast channels, a V-shaped profile also creates these really deep pockets in the side walls of the channel, which allow the concrete encasement to mechanically key in the channel for a strong and integrated installation. Channels with ductile iron edge rails rather than steel edge rails provide a more durable solution in road and infrastructure applications. Edge rails with anti-shunt lugs as well will also prevent longitudinal movements of the grates. Another option is a monolithic channel, meaning that it's all cast in one piece. These types of channels are ideal for roadways where the system would be running transverse across the carriageway and would be subjected to really heavy loads and lots of dynamic movement. In terms of loading, monolithic drains are available in a Class G, which is the highest load class in AS 3996. Another type of monolithic continuous capture inlet system is the slotted curb drain. This product combines two functions: the drainage channel with the curb itself. This is a shallow solution that requires less excavation for the installation, and therefore there's less likelihood of clashes with existing underground services. In this range, options include semi-mountable and barrier-type curb profiles, depending on the specific area within the roadway. The last system here are slotted drainage systems, and these are often manufactured from MDPE. This makes slotted channels really lightweight and easy to maneuver on site. So installing these channels is incredibly quick because you don't need cranes to lift them into place. Some slot channels are designed to be super strong when they're integrated into a slab. The arch opening, shown at the bottom right of the screen, allows reinforcement to pass through the arches to tie the slab together on either side of the channel without disrupting the line of the inlet slot and allowing for an unbroken reinforced slab detail. And here I'm just going to quickly run through some installation examples of where graded trench drains and slotted curb drains have been used on roads and highways around Australia. So for medians, curb drainage systems might be used to eliminate the spread of gutter flow into the traffic lanes by continuously capturing the water rather than traditional pit and pipe construction. Or you could use a graded trench style or a slotted style drain. For right-hand turn bays where you're trying to fit more lanes into an existing area, slotted curb drains can be a really helpful solution to give as much space to the roadway as possible. But some engineers or road authorities may prefer graded trench drains to slotted drains in this application. In curbside gutters where existing inlet pits are spaced too far apart, slotted curb drain could be used. Or again, a graded trench drain solution could also be used. Also on bridge abutments and tunnel portals, you can again use a slotted curb drain or a graded trench drain solution. For intersections, monolithic drains are ideal to prevent sheet flow from steep side streets entering a carriageway. Monolithic drains are also designed to intercept water from entering a rail corridor from a roadway. And lastly, monolithic drains again are ideal for use at property crossovers. A big driver on every project is cost. Precast slotted curb drains and graded trench drains are ideal for applications where curb inlet pits would otherwise be spaced closely together at intervals of 20 metres or less. It's just more expensive to install pit and pipe in these applications than a graded trench drain. This is an example of a road project where the designers opted for closely spaced pit and pipe, where a continuous capture inlet system would have been a more cost-effective solution. And we've carried out some independent install cost analyses of curb inlet pit and pipe systems compared to precast graded trench and slotted curb drain systems. The outcome of this was that graded trench drains are 15% cheaper to install than pit and pipe, and slotted curb drains 36% cheaper. So there are quite significant savings there to be had. We'll now look at shared spaces and the considerations that need to be made to correctly specify and integrate a surface drainage system that's safe for both motorists but also for pedestrians. Shared spaces are increasingly transforming city centres by combining transport hubs with public domains, and that brings with it some design challenges. And I'll share some examples of roads that have been transformed into shared spaces. On the left is a before image of Bank Street in Adelaide, which was transformed into the shared space on the right. The speed was dropped to 10 kilometres an hour and the curbs removed so pedestrians could move freely and share the space with vehicles and bicycles. George Street in Sydney has been converted into a shared zone with pedestrian, trams and some service vehicles. A flat space was created to ease the move of pedestrians by removing curbs and gutters. Graded trench drains and specifically designed tram drains were used extensively throughout this light rail corridor. Bundas Street in Canberra is a commercial and shopping precinct. In this shared space, vehicles give way to pedestrians at designated road crossings. Graded trench drains were used to outline the extent of the road, but also to intercept the runoff from pedestrian areas. These are some Victorian projects where curbs and gutters were removed and replaced with graded trench drains to allow pedestrians to move in all directions. And some South Australian examples of graded trench drains incorporated into nicely paved pedestrian areas that are also accessible by motorists. In the Hobart Airport project, a trafficable graded trench drain is used with different pavers and bollards to clearly segregate shared zones and pedestrian areas. And in Western Australia, a pedestrian-friendly precinct in Perth was converted from a two-way street to a one-way street to help to create that space for a dedicated pedestrian area. And lastly, some Queensland examples of shared spaces in an education precinct and in high-density residential areas. We'll now look at some key factors to consider when designing drainage systems within shared spaces. Ideally, shared spaces are located in areas with relatively flat pavements, and the surface drainage needs to be designed with an appreciation of the great slot sizes, slip resistance, loading, durability, and must be designed for both pedestrian and motorists to use. Uneven or steep pedestrian spaces will create trip hazards, particularly for the elderly, children, or those with a disability. Surface water management often leads designers to create steep pavements, but they can be designed flat if drainage is properly considered and incorporated during the design phase. A way to achieve a flat pavement is to use a graded trench drain with built-in slopes. This promotes efficient drainage of the surface. As we discussed earlier, precast trench drains with a V-shaped profile have hydraulic advantages over U-shaped channels, in particular during low flows, as the V-shaped profile creates higher velocities within the channel and promotes self-cleansing. Precast trench drainage systems are quick and easy to install, particularly when compared to cast in situ drainage or point drainage. The next element to consider are slot sizes, and slot sizes are critical for pedestrian safety, and we don't want to hinder accessibility for wheelchair and walking cane users. New building works must be designed to comply with the Disability Discrimination Act, which makes it against the law for public places to be inaccessible to people with a disability. Slot sizes of grates will also impact the safety of cyclists and pedestrians. AS 1428.1, the Design for Access and Mobility, was re-released in 2021. It's been updated so that slots 8mm and less can be positioned without restriction. However, slot sizes that are 8 to 13mm must be positioned outside of the dominant direction of travel. Bicycle safety is mandated by AS 3996. This standard takes into account the type of bar used in a grate and the maximum slot dimensions to stop bicycle tyres getting wedged in the grate. Heel safety is a really common complaint from pedestrians, and whilst there's no Australian standard for heel safety, there is an American standard that calls for slots less than 8mm. But there's a trade-off here between hydraulic intake and heel safety. So we don't want to see extremely narrow gaps that, whilst they are heel safe, they don't actually collect much runoff, and the drain becomes more prone to blocking up. So as a result, at ACO, we lean to a guideline of 10mm and less would constitute as a heel safe grade. Slip resistance is becoming a major concern for asset owners as litigation increases from slips, trips and falls. AS 4586 with a supporting handbook HB 198 stipulates the minimum slip resistance ratings for a variety of different applications. The standard outlines 3 test methods to simulate different applications as a means to assess the slip resistance of a grate. The oil wet ramp test pictured at the top of the screen with ratings of R9 to R13 is designed for industrial and commercial environments where there's likely to be animal or mineral oil on the floor. So, for example, in car parks or commercial kitchens. The wet bare foot test pictured at the bottom left of the screen has ratings of ABC and is designed for wet areas with bare feet, such as pools or changing rooms. And lastly, the wet pendulum test with ratings of P0 to P5 is the most widely used test, as it's the only test that can be conducted in situ. This test is most suited to areas that are rain affected, such as shared spaces and building entries. Next up is loading. And considering the anticipated vehicular load that a drain will be subjected to is critical. Underestimating this can lead to product failures, and overestimating it adds unnecessary costs. Load isn't just related to the physical weight of the vehicle. We also must consider the type and speed of vehicles, the wheel load, how the wheel will move over the grate, and the number of movements as well. AS 3996 is the Australian standard for access covers and grates, and this stipulates low-class requirements for grates, but it doesn't take into account the underlying drainage structure. AS 3996 classifies various load classes from pedestrian, which is class A, all the way up to aircraft pavements, which is a class G. Shared spaces will often fall into the low class C category, as shopping malls and pedestrian areas are open to slow-moving commercial vehicles. Road drainage should be specified as class D for major roads, freeway shoulders, and loading docks. The last element to consider is security, both to avoid theft and to reduce the risk of loose grates in trafficable areas. Using a boltless locking system on grates is a fantastic way to secure the grate into the channel, but it also allows for quick access for cleaning. The other option is to use bolted grates, but the risk is that bolts could vibrate loose during service. It's also quite common to see bolts removed during maintenance but not actually put back in place. Slot drains, like the image on screen, are often favoured in shared spaces because landscape architects like the discrete kind of drainage methodology. These also require inobtrusive access points to help preserve the visual continuity of the pavement but give access to the pipework. These access points should be installed at the start and end of every run and every 20 metres or so throughout for maintenance. Light rail is often the epitome of shared spaces, combining pedestrians with motorists and trams. And with state governments all over the country investing billions of dollars into public transport, we're seeing a rise of new metro lines and light rail projects that connect commuters from their home into city centres and create shared spaces around each station through highly trafficked pedestrian areas. Designers are being challenged to provide effective drainage solutions in very flat areas and with the complexity of draining the track rail grooves too. Specifically designed tram drains discharge the flow from the track rail groove through holes in the rail into a chute, which then connects into a trench drain and pipe system. The chutes are made from rubber and they isolate any stray currents from the track rails that could make the grates live. Tram drain grates should also be designed to take into consideration the 5 key factors that we discussed earlier. Wherever the drain is going, whether it's in a road, light rail, or a shared space, absolutely critical is selecting a drainage system that's going to work, whether it's going to do what it needs to do. The hydraulic performance of both trench drain and grate is really important. Now, the hydraulic performance refers to the amount of water a drain can collect in a given period of time, and that drives the product selection not only for the channel but also for the grate. An undersized drainage system can impact safety and cause property damage if the flows are not captured, but conversely, an oversized system just adds unnecessary cost into a project. So it's important that we get this right. The science behind the hydraulics of trench drainage is complicated, and there are many theories and equations to calculate it. And it's common for designers to use a simple pipe or open channel theory as means to calculate drainage capacity. However, this is assuming that the flow in the channel is uniform. So this works for culverts or pipes where liquid moves from one end to the other, but non-uniform flow is a more accurate way to model a trench drain's hydraulic performance, as it takes into consideration the collection of flow along the length of the run. Beyond the channel, the grate is the other consideration. So typically a channel will reach its hydraulic capacity before the grate, but depending on the style of the grate, it might not be capable of capturing all of the flow, even if the channel is correctly sized. And grate failure is categorized by the water bypassing the grate, as shown in the bottom image. Beyond the pure grate intake area, which is the open area of the grate, there are other factors that influence grate hydraulics, including the slot size and orientation. The number of slots and any raised slip-resistant nodes are also impacting the flow of water, as they can slow the flow down and help direct the water into the slots. With both channels and grate hydraulics, the only real way to know how they perform is to test them. And lastly, I'll touch on ACO a little bit, just in case you're hearing about our company for the first time today. ACO in Australia was established in 1994, and over the years, ACO has expanded beyond polymer concrete channel and pit production, and also manufactures stainless steel trench drains, rotationally molded plastic pits, and mild steel fabricated access covers, all from our head office at Emu Plains in Western Sydney. We also have offices and distribution centres Australia-wide for local service and quick deliveries. ACO product brands include ACO Drain, which is our range of architectural and commercial trench drains. ACO Infrastructure is our drainage channel range specifically for heavy transportation infrastructure applications, and it's a lot of what we've spoken about today. ACO Storm Bricks are modular underground stormwater storage tanks for retention, detention, and infiltration. ACO Access is a range of discrete access covers, and ACO Cable Mate is our cable pit and cable ducting range. Beyond our products, we also have a lot of support for designers, both with online DIY channel and grate sizing programs and tailored product support from our technical services engineering team. These DIY programs are a fantastic way to get really quick information on hydraulic performance of channels and grates. Hydrolite is our channel sizing program, and GIC is the grate intake calculator. Both of these are grounded in experimental test data. We also have another program called Scheduler, which can draw trench drain runs and provide layouts, long sections, and bills of materials to assist in procuring and installing products, which is particularly helpful if you're specifying sloping runs. AskACO.com.au is how we capture all of the services that we offer. So you can head to this site to access all of these programs for free and without obligation. And in case you want to dive even deeper into what we've spoken about today, we've developed 2 white papers in partnerships with Engineers Australia. The first is dedicated to understanding the hydraulics of trench drains, and the second discusses the importance of proper surface water management for pedestrianised pavements. We'll send you links to these in our post-event email this afternoon. And lastly, I wanted to introduce you to our dedicated technical sales team around Australia. I look after New South Wales and ACT, Helen is based in Queensland, Rochelle looks after Victoria and Tasmania, Andrew, SA and NT, and Maria is based in WA. Please do get in touch with your local rep. We'd be delighted to meet you and chat trench drains even more. Thank you so much for your time, and thank you again to Engineers Australia for hosting this event.
Thank you, Toby and Kate, for 2 great presentations. I'm sure we'll all agree. And thank you for all the lovely comments in the chat box too. So before we head into the Q&A, I'm pleased to let you know that we'll now be joined by Darren Chan, who's Brand Manager at Echo. Darren is the Brand Manager at Echo for Civil Construction Products and the NATA Authorised Representative for Echo's Testing Laboratory. And who continues to support engineers and designers with innovative products and free online design tools. We now have set up a short poll just before the Q&A, and I encourage you to get involved. And how you do that is if you could please scan the QR code on your screen or follow the link in the description box. The results will show up on screen as you answer. So I will start with question 1, and question 1 is, where do you see the greatest drainage challenge? And the options are crossovers, super elevated transitions, medians, or curb lines. And I'll give you a few seconds to respond. Oh, I think those results are starting to settle. Darren, do you want to just comment on what we're seeing with our audience?
Thanks, Amanda, for the introduction before, and thanks, Toby and Kate, for great presentations. I'd like to thank everyone for participating in this poll. It helps us as manufacturers understand what challenges that you designers and engineers out there have. And looking at these 4 categories, it's clearly that super elevated transitions are a great challenge, and okay, we understand that too. Putting a cambered road in and then you put a median through it, you're really just blocking the flow from one side of the road to the other. So therefore, it's the challenge of putting in a drainage system in the middle of the road amongst all of the other infrastructure in the ground. So that's always been a challenge, and ACCO have come up with some good solutions, and we understand those solutions with continuous capture inlets that Kate presented, with curb drains and graded trench drains that are used in those areas. Crossovers are also a sort of an area that you see a lot of damage in, especially if you look at going through a petrol station or service station. At the entrances and exits, that's very an area where there's a lot of dynamic loads, where there's cars, trucks braking and accelerating, that causes a lot of pressure onto the drains, and where you see breakages. So it's really important in those kind of areas that to specify the correct strength drain and the type of material. Curb lines is also not as I suppose a big of a challenge, as you usually have some shoulder to work with. So there is areas where drains can have a width of flow as long as it's not encroaching onto the roadway for safety for motorists. So thanks for those answers. It helps us look into providing more products and solutions for those kind of applications.
Thanks. Thank you, Darren. And we've got two more questions to go. The next one being along a tight curbside gutter, if curb inlet pits cannot be accommodated, what is your linear drainage preference? A, curbed profile inlet drains, B, continuous channels with removable grates, C, continuous channels with non-removable grates, and D, continuous single slotted drains. We'll just wait a few seconds to give you time to answer. So Darren, I think we have one that's well out in ahead, continuous channels with removable grates. Do you want to just comment on that one too? Thanks, Darren.
Yeah, look, curb inlet pits and pipe systems, they're the traditional way of collecting water, and it serves its purpose when there is grades along the road. Where continuous capture inlets come in is for very flat areas. So for continuous channels with removable grates, that's very popular with the road authorities. They come in different depths and widths that are available to capture whatever flow you need. So they're very flexible. ACCO, we supply slope channels too. So it's very flexible in flat areas where we can provide a fall along the invert. Curb profile inlet drains are also been popular with the road authorities too, especially when there's very tight space constraints. With the curb inlet, the curb face is your inlet hole, so you're really not reclaiming much more of the roadway compared to a continuous channel where it's actually needs some space on the roadway or on the road to be installed in. So with a curb, for very tight areas, the curb profiled inlet slot drains, the slotted curb drains are the best option. Continuous single slotted drains, they're very narrow. They serve its purpose, but they can be easily blocked up. So might require more maintenance with those ones. And then the continuous one with non-removable grates is the best option for when it's across the traffic lanes.
Thanks. Thank you, Darren. And our third and final question. What do you value from a drainage supplier? And if you could rate 0 for the most least important, 5 for the most important, being A, downloadable drawings, data sheets, B, hydraulic services, C, pavement/structural integration advice, D, drawing, run scheduling services, and E, phone face-to-face assistance. Thank you. Thank you, everyone. Darren, if you'd just like to comment on our final question before we head into the Q&A. Thank you.
Oh, thanks, Amanda. As manufacturers, we like to back up our products, and how we back it up is through what we can provide engineers and designers to help them specify the products into their plans. So downloadable drawings and data sheets, we cover that. ACCO has a suite of data sheets and drawings within our website. Just head to the downloadable section, and there's installation drawings, there's product data sheets that you can download. Pavement structural integration advice, there's installation drawings in different pavement, such as concrete, asphalt, pavers. We have a technical service team that provide hydraulic services, so you can tell us the amount of water that you need to collect, that we need to collect in the drain, and we can help you size up the drain. We can also help you provide pit spacings, depending on the capacities of the trench drains. And yeah, we're always looking for ways to provide a service that would back up the products and help you provide a good design.
Thank you for that, Darren, and thank you for everybody for participating in the poll. Now with the questions, and please submit your questions via the YouTube chat box. And thank you for people who actually put through questions when they were registering for today's event. And we've had a cracker to start with from Patrick in ACT talking about climate change, which is quite topical as of it today, and tomorrow is Engineers Australia's Climate Smart Engineering Conference in Adelaide. Toby, Patrick is asking you, how should designers include climate change in their designs for roads and other urban areas, given the significant increase in design rainfall estimates from AIR v4.2? Thanks, Toby.
Thanks for the question, Patrick. Yeah, it's a great question. Very commonly discussed between local government organisations, consultants, developers. So yes, we need to include climate change for roads and other areas. We consider it by selecting a shared socio-economic pathway, SSPs, from the ARRR, for those who don't know, Australian Rainfall and Runoff. It's currently up to individual organisations to choose an SSP. So we need to be considering the design life of the infrastructure and the risk involved with underestimating or that infrastructure failing. From my experience, kind of SSP 3 to 7 is most commonly selected. But yeah, again, it depends on the individual organisation to make that choice.
Thanks, Toby. We've had a question for you, Kate, and also for Darren, and it's coming from Kingzang, who is watching in WA, asking you, Kate, how do you drain out the surface drainage water in plain areas where there is no low point? Thanks, Kate.
Thank you. So, in areas where there's no fall, sloped channels are a really fantastic way to effectively drain pavements. It's kind of essentially creating the low point within the channel itself, whilst you keep the pavement flat as well. Darren, have you got anything you wanted to add to that?
Yeah, that's always been a challenge, to keep ponding and water, I suppose, off the road for the safety of motorists from aquaplaning. In pedestrian areas where there is very flat areas, you don't want ponding that can contribute to slips, trips, and falls. So it's very important to get the water off the pavement. So a good drainage design will also go hand in hand with a good pavement design. Your pavement's got to be designed to construction to fall the most quickest and efficient way into the drain, and then the drain has got to be able to get it away. So in flat areas, as Kate mentioned, your top of the channel or grate is flat. ACCO can provide slope channels. Our slope channels have a 5 millimetre fall over 1 metre, so a 0.5% fall, and this will promote hydraulics for all the water flowing towards the outlet to discharge. So yeah, in flat areas, always think of having precast channels with inbuilt slopes in it will help.
Thanks, Darren. Thank you for that. Toby, we've had a question from Giovanni, who is watching in New South Wales. Good afternoon to you. Asking you, Toby, how is drainage infrastructure in metropolitan areas coping with the increase in demand due to population growth?
Thanks, Giovanni. Population growth of developments, if designed correctly, shouldn't be negatively impacting existing drainage. The new drainage should be designed to cope with the development land use, as well as considering any existing drainage kind of upstream or downstream that it's connecting into. There's a good table in the IDM showing different impervious area factors for different land uses. Old drainage infrastructure in metropolitan areas, that's where we can start to see problems with increased intensity weather events due to climate change. For these, we treat the problems reactively as we kind of find them, and we complete flood studies to identify problems proactively so we can hopefully get ahead of the storms.
Thanks, Toby. Darren, we've had a great question from Michael. Michael's watching in Queensland, talking about Australia-wide standards. And the question, Darren, is should we be moving towards Australia-wide standards for design elements like drainage pits and treatment systems, when it comes to design and construct projects? With more and more engineers working on interstate projects, this would improve efficiency across the board and reduce having to know all the individual manuals for council, state and federal. Darren, big question.
Thanks, Michael. Yeah, that is I understand that is a issue with designing many projects over borders, over state borders. We understand that every state government, I suppose how Australia is set up as a federation, we are made up of all little colonies, 6 states and 2 territories, and with that, with each individual, I suppose, state and territory also have their own road authority with their own ideas on how to design things. So it is a challenge we see for you engineers designing across state borders to understand each of the different requirements of those. So it's a hard one. You can't really change the constitution in our federation and how we're put together, but there are Australian standards, as Toby and Kate mentioned in their presentation, AS 3996, which is the access covers and grates, which is looked upon by all jurisdictions as the Australian standards for loads, ratings for access covers and grates. So that's a good thing. But even Austroads, is sat, Kate mentioned, it's sat by all the road authorities from around Australia, and they sit down and they come together and put together a document that sort of gives you a guidance on how to design drainage in roads, which is hopefully helpful. But looking at each different states, it's a sort of an issue for manufacturers too. Just to give you an example, ACO developed that curb drain system. So the first curb drain we sort of matched was the Transport for New South Wales curb, the SF curb. The SF curb is 130 millimetres high, and that was okay. It was perfect when we designed the top of the curb drain. It just seamlessly joins onto the SF curb. So if it's joining into a precast curb or slip form curb, it'll just look seamless for your aesthetics. But then we've had issues where we tried to use that same 130 millimetre high curb in Western Australia, where they call up a 150 millimetre curb, which caused all sorts of issues because it wasn't seamless in connection. So what ACO did, we had to invest in some molds, new molds, to match the MRWA curb, semi-mountable curb. So we come up with a semi-mountable curb profile that matches seamless into that. And then if you look across most road authorities, they will have a slight variation to those two, 130 high for New South Wales and 150 high for WA. But as ACO, we're willing to invest in products that meet, I suppose, the asset owners' requirements, and that's what we've done for both WA and New South Wales. So yeah, it's an issue, I suppose, with us as manufacturers, and we understand your issues too with designing over different state borders. But yeah, that's what we want. We want something that's all the same Australia-wide, so then it will become efficient, but I don't think that will be happening anytime soon.
Thank you, Darren. Toby, we've had a question that's come in from Kukuna in WA, asking you, Toby, What are the factors considered when we say 1% asset earning power and 10% AEP events? Where are we getting precipitation data for the last 50 years or so for designing drainage? And what is the factor of increment we are considering while forecasting weather for the next 30 to 50 years? Toby.
So precipitation data comes from the Bureau of Meteorology, the IFD, intensity, frequency, duration. So there's baseline data that we work off for our flood modelling and rainfall. For forecasting future events, circle back to when I was talking about shared socio-economic pathways, our SSPs, and that's where we're actually considering different climate change factors and I guess assuming where global warming, global temperature increase will be for a specific year. So our SSP choice will actually change our results quite a bit. The further in the future we're looking, the more effect the SSP will have on the results. I mentioned before there's a good table in the IDM and in Australian rainfall runoff as well that shows 4 SSPs modelled and where they're looking like they will be for the next 75 years.
Thank you, Toby. Kate, a question for you and then for Darren as well from Theodorus, who is watching in Victoria, asking you, Kate, can you confirm slip resistant results for pedestrian surfaces for both wet and dry applications?
Yeah, thank you. So slip resistance requirements are going to vary across different types of pedestrian area. Most of the guidance is in HB 198. So I mentioned that in my presentation. This is the handbook that goes with AS 4586. That relates mostly to internal applications, but there is some external guidance. So, for example, using the wet pendulum test, HB 1998 requires ramps to have a P5 rating, shop entries are a P3, and loading docks are a P5. So it's a bit of a mixed bag. Really critical, though, is making sure that all of the flooring material has the appropriate level of slip resistance, but that it also matches. So, like the floor, whether it's pavers or tiles or concrete, asphalt, whatever, matches the slip resistance rating of the drainage grates and also the access covers as well. Darren, have you got anything you wanted to add to that?
Yes. So we both wet and dry applications. With dry applications, that's usually the time when it's not that slippery. So most of the materials, grates, tiles, pavers, they'll be fine in a dry. And there is a dry floor friction factor, or that is in AS 4586 to test for that. But it's not really called upon by, I suppose, councils and governments that specify pedestrian surfaces. So it's when it's wet is that's, I suppose, when it's more slippery surfaces, paving, tiles, even grates, and when it gets wet, that's when it becomes the concern. And in AS 4586, it's the wet pendulum test that will provide you with a P rating. It's really important for specifiers and engineers to design the level of slip resistance required for that application. So otherwise, I suppose you can slip resistant is through other testing, which could be if it's in industrial areas, then you'd go for the ramp test, as Kate showed in her presentation, the all wet ramp, and that's more applicable to oils and greases. But in AS 3996, there's also a section there that specifies what slip resistance is required in pedestrian areas, and they say as long as it's a P3, P4, P5, but it's best off if you understand the application and use HB 198 as your guide to specify the correct slip resistance for that area.
Thank you for that, Darren. Toby, question from Shahab. asking you, what if a tree is categorised as cultural heritage or environmental? Then what's your approach then? Thanks, Toby.
So it wasn't the case in this case. If we needed to consider tree removal, we'd have to consider, I guess, yeah, that specific tree. If there was a need for a cultural heritage management plan, perhaps consult with statutory planning, and possibly even with Department of Energy, Environment and Climate Action, DECA. Luckily enough, in this case, we wanted to protect the tree anyway, so we found a solution where we didn't have to complete any works on the tree. So if this was a tree that had additional significance, we still could have proceeded with the project.
Thanks, Toby. Darren, a question has come in from Sobranium, who is watching in New South Wales, asking you, Darren, for surface drainage in roads and pedestrianised zones, what are the most advanced eco-product take a primary importance in saving pedestrians while walking?
Thanks, Subramaniam. With ACO, we've got a range of grades for pedestrianised areas, pedestrian safe grades. We call those hill safe anti-slip. And if you look on at our products, the classic drain range, we've got a whole suite of grades that meet our hill safe anti-slip requirements. So that means for hill safe, it's got a 10 millimetre slot or less width. It's bicycle safe. It's also been slip rated, so you can check on the data sheets and see what slip rating that grade meets. And it also meets AS 1428.1, which is the Access and Mobility Code. So these are your DDA requirements, and they specify what size slots grates are allowed. So with our hill safe anti-slip range of grates, they're the ones that you should specify for pedestrian areas, as it meets all those, or it's been rated and it meets all those requirements. So with the hill safe anti-slip grates, we've got a whole different range of grates with different slot patterns, different materials. We've got stainless steel grates. Our 5-star grade is very popular. A lot of architects specify that, and it's got an actual P4 rating. The other big seller is our intercept iron grates. They're more your, stronger industrial grates that you'll see mainly in shared spaces, especially throughout the Sydney CBD, and most CBDs are around the country. And there's also, we've got plastic grates and also galvanised steel grates. So there's all different types of grates that we can supply to meet whatever aesthetics that the designer likes, that wants for that area, and they meet all of those legislative requirements.
Thanks, Darren. Thank you for that. We've had a question that's come through for both Kate and Darren. So maybe starting with you, Kate. Question is, some existing trench grates have sizes that are no longer available in the market, thus requiring us to fabricate them from load bar grates, which does not have Class BD class. Is there an easy way to classify them as Class BD instead of requiring a designer from time to time? Kate.
Thank you. This comes up from time to time where there's an existing drain that has some grates that have failed. We often, perhaps we'll hear about this where it's not in a public space, where the designer or the asset owner is just looking to replace some of these grates that have broken. And so with the old products from other manufacturers, it's often difficult to find out whose is who and find a matching grate that you can just sort of drop into place. Certainly in public spaces, replacing both elements of the channel and the grate would be recommended to make sure that the two elements integrate well together, so that the channel is functioning the way that we need it to, and is capable of dealing with the low classes that match with the grate as well. So there's a couple of parts to that there. That will also, like using a proprietary product, it also gives you certainty then over the load classes, and yeah, just choosing from an existing kind of range, I suppose. Load testing to AS3996, Darren does a lot of this with his NATA test facility. This does require a test lab, so it's just not really feasible to do it for one-offs, and certainly not something I would imagine that steel fabricators would have access to. But perhaps, Darren, I'll hand over to you if you want to talk a little bit more about the load testing in AS3996.
Thanks. Yeah, like with all these, I suppose, broken grates that are probably been installed, been overstressed, they've been damaged. Sometimes, I suppose, the channel also gets damaged. If the channel is also damaged, it's probably best off if you replace the whole trench drain itself instead of just replacing the grate. Or in most of these cases, what I've come across is all they do is if it's in a concrete pavement, they'll just saw cut the trench drain out, and then with a precast drain like ACCO's power drain or classic drain, you can easily reinstate those into existing slabs. The good thing about that is all ACCO's grates are tested, and we can provide a NATA endorsed load test report for them. Otherwise, if the channel's still good, it's been a stain or a metal grate that's been damaged, you can get an engineer to design it up from first principles. What kind of load bars is required for that application, depending on what vehicles are going over it. We can design it from first principles. Otherwise, it's sort of we can design something up, and then you just take it to a test house that can test the AS3996, and then they can either classify it to whatever you designed it to and confirm it to Class B or Class D, if that's the case. AS3996, there's a lot of test houses out there that you can go to that manufacturers, fabricators can take their grates. Good thing about ACCO here is we've invested in our own NATA test facility, so we can actually test to those requirements of AS3996 and provide a NATA endorsed test reports. Our test facility gets audited every 18 months by NATA. Our instruments are all calibrated, so yeah, you can be reassured if you come to ACCO, install an ACCO drain, we can supply a test report to Class B or D or whatever it has to be.
Thank you, Darren. Toby, we've had a question from Mark asking you, Toby, were there any load calculations carried out for the channel to see if it could carry footpath loadings without the need for the narrow vertical support plates that were added? Thanks, Toby.
Yeah, it's a good question. For the purposes of this as a test case, I worked pretty closely with our in-house design team. We did end up, I guess, over-engineering the channel a bit. Live load calculations meant that it was probably just a bit too close for comfort. So yeah, we decided to put in vertical support plates every 500 mil. If we're looking at larger scale, we'd certainly be looking at optimizing the design. We could look to remove the vertical supports if we increase the top flange thickness, possibly had a shorter length for the channel. This one was 3 meters long, which is getting up there for taking a light load if we had something like a postie bike drive over the top of it. Another option would be to possibly have a deeper channel. Then we'd need to consider the front plate supports again. They might need to be either shorter spacings, but more likely just increased thickness so that we still had good openings up each end.
Thank you, Toby. Darren, we've had a question come in from Ash. Good afternoon to you. Asking you, Darren, do grates require a founding slab under the grates to be installed? And if so, how can they be tied into existing concrete pavements adjacent to the founding slabs? Darren.
Thanks, Ash, for the question. That is a challenge for designers. Depends on what type of trench grate you want to install. There are, as I said before, you can if it's a damaged grate or you need to add a new grate into a slab, you can just concrete cut out that area and then cast in a concrete encased precast drain like an ACO drain into those areas. But to tie in I suppose what you're probably alluding to is to tie it in with the other slab, you'll probably need to use dowel joints by drilling holes into the existing slabs and putting dowel joints. That'll help you that'll help you with differential settlement. So yeah, on ACO's website we actually have a little technical bulletin that discusses how to do this into existing slabs with a few diagrams and how you can tie in your dowel joints for a complete solution.
Thank you, Darren. Kate, we've had a question that's come in from Danny, both yourself and Darren, asking, cars driving over grates often make a high impact noise. Is this noise taken into account in the design of the grates?
Yeah, thank you. I'm smiling because I have some lived experience with this. So in my old apartment building, we had a grate and frame and loose grates. And all day and all night, I would hear these clunking grates. And, I have a sensitivity to drains that a normal person probably doesn't possess, but it's quite frustrating. So certainly, yes, locking grates into the channel will prevent that. So what we've designed is the two elements that join together. So you have the grate that will lock into the channel. So how we do that is using a boltless locking mechanism so that it's kind of quick and easy to get into the channel to be able to maintain it. And we also have anti-shunt lugs in our grates as well. So it stops the grate kind of moving longitudinally as well. So they're using a product like ACO drain or plastic drain or power drain is a really good way of minimizing that risk. Also, aside from just like the noise kind of complaints of it, it can also be detrimental to the channel itself and the grate too if those two elements are kind of moving independently. The other element of this the other option that you could do is to specify a monolithic trench drain. So like that they are ideal for crossovers so that the grate, there is no kind of separate grate to rattle within the channel itself.
Do you want to add to that?
Yes, with grates, that's probably one of the challenges we have. With all grates and even precast drains, the grate's made of metal, the edge rail's made of metal. So obviously if there is any movement on it, there will be some noise coming from as a vehicle passes by. So what we try to design is a nice snug grate that fits within the edge rails or frame. So to prevent that movement, as Kate said, we've got anti-shunt lugs that protrude down from the bottom of a grate and sort of positions itself in the edge or frame, so it doesn't slide longitudinally along the trench drain. And also, it must be locked down. So if it's not locked down, if it's loose, it's always going to rattle. It doesn't matter what you do to it as a vehicle goes over it. So yeah, all these crossovers into buildings and all that, you just got to ensure when you specify a trench drain across those areas that you specify that it's got to be lockable and locked down tightly. And and half the issues is with maintenance too. As long as the maintenance people lock it back down after they clean the drain, then it should function fine without any noise.
Thank you. And we're coming to the end of our Q&A, and we have covered a lot this afternoon talking about surface drainage in roads and pedestrianised zones. So starting with you, Toby, and then Kate, Toby, could you just give our audience a few key takeouts for about a minute of your presentation, and then Kate, if you could do the same. Toby.
Sure, thanks. Yeah, well, I guess looking at drainage, we can simplify it. It's going to run downhill. Often we're going to have a start and a finish point and lots of points to work into. Our design's going to, or needs to include all the existing infrastructure and services in the way. Drainage is often an afterthought, or we find a problem and we have to fix something. So yeah, it's not as simple as it sounds, just getting water downhill, but it's how we get there. And I think we can always look for innovation and look for new ways. Innovation versus status quo. Sometimes we need to be looking for new solutions and hopefully find new ways to make things easier for the future and make them more efficient.
Fabulous. Thank you, Toby. Kate.
Yeah, thank you. I guess really just to echo what Toby was saying there, that really it's harder to fix a problem that's already there. We can kind of prevent that from happening by considering drainage really early on in the planning phases, so that we can create shared spaces and roads that are safe for all the users, and just mitigate some of those issues that do come up, like those rattling grates and load classes, just by specifying a proprietary product that meets the user requirements for that particular project. And there are so many different drainage options within the market and within ACCO's range. And really just a reminder that we've got this national network of specification people to help you when you're choosing products for your projects, but also trench drain sizing and product support in generally. So please, do get in contact with your local specification representative, and I'm sure they'd love to chat more specifically about your project as well.
Thank you, Kate. And some exciting news that I'd like to share, that we have a competition this afternoon from ECHO. If you could, please share your answers to the email on the screen, and there will be a gift card prize from the competition winner. And the question is, can conventional curb inlet pits be replaced by trench drains? What are the considerations? So I urge you to enter. You've got to be in it to win it, as they say. We have pretty much run out of time this afternoon. It's been a really interesting discussion and conversation. And please join me once again in thanking Kate Jennings, Toby Hoy and Darren Chan for their generous time and input today. I'd also like to thank Engineers Australia's industry partner, ECHO, for their ongoing support. And as always, we're always looking for ways to improve and plan. So if you could take 1 minute to complete a short feedback form, which is linked in the description box below, to help us improve and plan for future sessions. Thank you again for joining us, and I look forward to seeing you at our next Industry Partners event. Thank you and good afternoon.